Hello from London. I'm Dee Dee Doak, Head of Content for Airlines. Welcome to our webinar today, Advancing Aviation Safety with Technology, brought to you by Airlines Magazine and Honeywell. We have an exciting panel of speakers today. We have Gerardo Hueto, Assistant Director, Safety and Flight Operations for IATA, Alois Sant Johanser, Senior Director, Airlines Avionics, Christoph J. Kemeny, Captain and TRE Lufthansa CityLine. Now, during our webinar today, you're going to see some poll questions come up on the screen. Be sure to take part in our polls. Also, I'd like to remind you that if you would like to re-listen to the webinar after the presentation today, it will be available on demand on the website. First, our speaker today is going to be Gerardo Hueto. Over to you, Gerardo.
Thank you, and good morning, good evening, everybody from Singapore. I thought I would share with you today, first of all, I want to clarify, I'm Assistant Director of Safety and Flight Operations for the Asia-Pacific region of IATA. And I thought I would share the latest safety information that we have in our safety report, our annual safety report. So with that, I'm going to advance the slide. Hopefully everybody can see it right. 2018 was a year with a fairly high number of accidents, 62 total, and a fairly high number of fatalities on board the airplanes, also 523. It's as you're going to see in the next slide, this is a sharp increase from the year before. And now looking at this slide, the blue line is the accident rate per million departures or per million sectors for IATA member airlines. The green line is the accident rate for the whole industry, and the yellow line on top is the accident rate for non-IATA member airlines. And as you see, like I told you, we went up, all three sectors of the industry went up in accident rates when compared with the last 5-year average. However, the trend is still, if we look at the 5 years, a downtrend. We keep tabs on accident rates by region, and here we can see that in 7 out of our 8 regions, the accident rate has increased. The bottom number is a 5-year average between 2013 and 2017. The one in the middle is the rate for 2017, and the blue number on top is the accident rate for last year, for 2018. As you see in the bottom left corner of the slide, the world accident rate increased from 2017. However, it's lower than the 5-year average. It increased both for IATA members and non-IATA member airlines. Where we saw a sharp increase is in the number of fatalities, 523 last year. Still, IATA members have the lowest fatality risk, counting accidents per million sectors. However, this has been an increase, and it's the same rate basically we had in 2015. When we look at this risk, it increased in 5 of 8 IATA regions. Asia Pacific, CIS, Africa, Latin America, and the Caribbean are the ones that saw the rate go up. IATA members had a slightly higher rate, but still lower than the average of the last 5 years. and the world also saw an increase from 2017. Now we look at jets and turboprops because they seem to have generally different rates. And what we saw last year for jets was a sharp increase in fatality risk. Again, the blue line is IATA member airlines, the green is all industry, and the yellow is non-IATA members. This sharp increase was mainly due to 3 accidents, one in the CIS, in Russia, one in Cuba, and one in the Asia Pacific region. By region of the world, this jet fatality risk stayed the same in 4 regions. It went down slightly in Europe and increased in Latin America and the Caribbean, and the CIS, which is the Confederation of Independent States. IATA members, however, had a 0 for 2018 and 2017, while the world went up. As far as turboprops, there's another sharp increase, this time with IATA member airlines. This was due to an accident in Iran that had no survivors, and it was a controlled flight into terrain. And for turboprops, 2 regions of the world saw an increase in fatality risk, Africa and the Middle East and North Africa. Remained the same in 4 and decreased in the CIS and North America. When we look at what caused the most fatalities in 2018, in this chart what you see is the accident frequency on the vertical axis and the fatality risk on the horizontal axis. The size of the bubbles depends on the number of people that perished due to that type of accident. We see loss of control in flight, 372, controlled flight into terrain, 66, runway and taxiway excursion, 52 passengers. Now let's look at the last 5 years for this chart, and it remains pretty much the same, with loss of control, CFIT, and runway excursions being the top 3. When we include 5 years, there's unclassified accident there, other end state with 314 fatalities. That is Malaysia Airlines 370. We hope one day we can properly classify that accident. So if I were to go back another 5 years, the situation wouldn't change much. These 3 types of accidents have been occurring for a long, long time in the system, with runway and taxiway excursions not being the most fatal, but the most frequent accident for the last 10 years at least. When I say IATA member airlines, now I'm going to make a distinction between IATA member airlines and IOSA operators. It is a requirement for IATA membership to be registered in IOSA and pass the audit. However, there are many non-IATA member airlines that are in the IOSA registry. We have more than 430, when we have about 290 member airlines. We do this chart by region of the world, and the yellow sector is non-IOSA airline accident rates, and the blue sector is IOSA registered airlines accident rates per million sectors. The situation varies by different region of the world. In the world at large, which is the bar at the extreme right, IOSA registered airlines have less than 1/2 the rate of the non-IOSA registered airlines. However, when you look at regions like Africa and the CIS, the difference is very significant. Same in Latin America and the Middle East. Now, I'll briefly go over on what we see as causal factors for these three types of accidents. And we have worked with many international organizations in the Americas, in Europe, here in Asia Pacific, with ICAO, to try to analyze some of the top contributing factors to these accidents. So for loss of control in flight, and in this we have consensus with the Commercial Aviation Safety Team in the US and with EASA in Europe, we see lack of airplane energy state awareness or system state. And an emerging issue last year was an aeroplane system malfunction. By the way, the final report for that accident is not out yet, so it's been pre-classified as a loss of control, but we may have to review it or reclassify it once the final report is out. Some of the mitigations available for this type of accident, we have a guide. It's free. You can find it at that link. We revised it last year. It's Subset Recovery Training Guidance. The Commercial Aviation Safety Team, which we are part of, has produced a couple of safety enhancements that are available in Skyberry, and there's a link for you if you want to find more information about those. Basically, enhance the CRM training and pay more attention to the training for go-arounds. When it comes to control flight into terrain, this is an accident we thought that we were going to totally get out of the system with terrain awareness warning systems. And it was greatly reduced. However, not to the extent that we want to have it reduced. So the factors we see contributing to this are loss of situational awareness, lack of the equipment, lack of technology, or outdated software, or no GPS in the airplanes. For this, around 2006, 2007, there was a safety enhancement published by CAST that has been widely adopted by airplane manufacturers. It's an update of the EGPWS software and connecting it to the GPS. I would say most airplanes delivered after probably 2008 or 9 already have the software version. However, for older airplanes, it's worth looking at that link and making sure for most airplanes there should be a free software update. And it greatly reduces false warnings and increases the accuracy of the system. Also, the adoption by air navigation service providers of minimum safe altitude warnings. And we, in our flight data exchange metric, have an EGPWS tab that we keep checking every quarter to see if we can reduce the number of these events, which are precursors to CFIT accidents. For the third one, we really bundle and we call them approach and landing type of accidents. We include runway excursions, undershoots, overshoots, so landing before or after the runway, and abnormal runway contact, which we landing in a way that causes the aeroplane to break, like the recent Sukhoi Superjet in Russia. The contributing factors we see, and these have been the same through the last few years, are unstable approaches, undesired states of the airplane, the failure to go around when the go-around maneuver needs to be executed, weather, of course, runway conditions, late runway changes. We do have a new edition of our risk mitigation for unstable approaches guide. There's a link for you, and it's again free. And we work with the cast on the development of those two safety enhancements. They're in the same Skybrary webpage where the ones in the previous slides were. We also, with the Asia Pacific Regional Aviation Safety Team, have developed regional safety enhancements to prevent unstable approaches. The manufacturers, notably Airbus with the ROPS system, have also developed technology to prevent runway excursions. This is all I wanted to share with you today, basically a brief introduction to where we see the risks in the system. And I'd like to thank you all very much for your time and pass it on to our coordinator.
Gerardo, thank you so much for that very insightful presentation. We are going to be moving on in just a moment to Alois Sankt Johanser, but in the meantime, I'd like to remind our audience that we would like to get your questions to our panel. At the end of our webinar, 45 minutes in, we will be taking your questions and presenting them to the panel. I'd also like to remind you to please keep an eye out on your screen for our viewer polls and do take part in them. Well, now we are going to go to our second speaker, Alois Sankt Johanser, Senior Director, Airlines Avionics with Honeywell, and he's going to be talking about advancing aviation safety with technology and Honeywell Safety Solutions. Over to you, Alois.
Thank you very much, and also a very warm welcome to all the listeners from Munich. What we are going to cover today is safety risks in aviation, runway excursions, incursions and landings, weather hazards, air traffic. We also talk about the second topic, addressing the risk with technology, for example, the ground proximity warning and the advanced runway advisory system. We will talk about GPS systems, 3D weather radars, and then we will present a short mandate reminder. Another thing we have in this presentation is a special feature where we look at an accident which was happening on a runway and is part of a CISA project. So I think everybody is aware of the aviation pioneer Amelia Earhart, and if you look at one of your statements there, trouble in the air is very rare. It is hitting the ground that causes it. So that's a fascinating statement, definitely very true, and this statement was made before 1937. So it's very impressive because today I think this is still very valid. So before we move on to the runway safety solutions, the incursion and excursions prevention, I would give it to Vicky real quick for the poll questions. So we give it a couple of seconds. So for the audience, if you could please answer those, and then we will go, as we go through the presentation, we will get feedback what the actual figures are. Okay, so before we get the answers back, I'm going to move to the next slide. So basically, I thank Gerardo to highlighting the current state. So what you see on the slide here is, today's challenge, and it looks and data are proven that 41% of all the accidents, they occur in a runway environment. So runway excursion is the most frequent type of accident. And this is why all the safety organizations, including IATA, they make this goal of number one priority to help and improving the runway safety. And if you see here on the bar chart, on the bottom, you see like 3 indications which are red. So those are number one, the runway taxiway excursions, then the hard landing and the tail strike. So if we look at those things, for example, and we look further into those safety reports, you see that during the landing, the approach and the go-around are the most contributing factors. On the right side, where you see this little red box, it shows the top 3 contributing factors on an undecided aircraft state, and it's clearly the long floated, bounced, firm off-center or grabbing landing, a vertical lateral speed deviation, and definitely the unstable approach. So the recommendation to operators is to implement a policy of landing in the touchdown zone or consider a go-around, implement a policy of go-around from an unstable approach, and we just want to highlight again that unstable approach is a top contributor, and then deploy onboard technology to reduce or prevent landing overruns. So if we look at this little chart here, if you follow this, what are the factors on an approach leading to runway excursion? So if we start on the top left side where you see the aircraft, this is where a pilot might have asked, is the landing configuration established, meaning are the flaps set? And then if you follow down the more thick line at the very bottom in this little red stripe between 300 and 400 feet altitude, at that decision height, when you get closer to the touchdown zone, you might ask, am I actually aligned with the proper runway? This could be, happening if you have an airport with parallel runways. So this is a very important information. Or am I unfortunately trying to target a taxiway, which is also happening pretty often if you look at past history. If you follow the line which is from the top of the aircraft, where it goes a little bit forwards, where the aircraft is above the glide slope, for example, then typically the tendency is to do a nose down command to capture the glide slope again. But then this would mean you have a speed increase. And as you continue your descent and you try to capture the glide slope from above again, this is where you might go into this unstable approach condition. So there is a critical decision factor, altitudes, to make a decision about am I still able to land the aircraft safely? Do I need to do a go-around? So this is where we will see a couple of statistics about the decision making here. And then certainly, as you try to really go to the touchdown zone, am I flaring too long? Do I miss the touchdown zone because I, keep the aircraft in the air? Is the eventually runway getting too short to land safely? So those are all questions which are factors leading to runway excursions. So this is a case study from Emirates Airlines, and this goes back, almost 10 years now. So Emirates, they wanted a system which improves the taxiing and landing safety. It should complement existing pilot safety procedures, and it should be somehow configurable so they could use the standardized configuration amongst all their fleet with minimum training. So the solution provided was basically we looked together with Emirates on the data, And then we developed together and tested and certified the new safety solution, which we call Smart Runway and Smart Landing. And the benefit is definitely that there is a reduced risk of runway incursion, excursion, and it's resulting in improved safety and cost avoidance. And the system can be used at all Emirates airline platforms around the globe. And also there was a high emphasis taken on that the training is minimal because it's an add-on to the existing technology. So the technology breakthrough at that point, this was really going beyond enhanced ground proximity warning system with, adding additional software function which provides, or addresses almost all of those things we have seen in the chart where the landing, the glide slope was represented. So in the IATA safety report, the conclusion was that stable approaches are the first defense against runway excursions. And if you sequence to the right, we made it possible by implementing a software feature alerting the crew to an unstable condition regardless of runway length and allows them to address instability before a go-around becomes necessary. So this also reinforces the proper pilot procedure. And the next IATA safety conclusion was that the final more important defense is landing in the touchdown zone. So if there is little or no visual reference to identify the end of the touchdown zone, the new software upgrade alerts the crew to landing beyond the touchdown zone regardless of the runway length. So there is a lot of data contained in the enhanced ground proximity warning system to support this. So Honeywell did also a study of 17 different runway excursions, and what we found is that 41% they would have received an unstable approach warning. 85% did not land in the touchdown zone and would have triggered a long landing call-out. And the customers with a long landing active call-out are reporting tighter groupings of the touchdown points. So this is all basically positive feedback. There are certainly other systems from OEMs which also use the enhanced ground proximity warning system. For example, there is the so-called RAS feature, which customers can order from Airbus or Boeing directly as a line fit, and it could also be retrofitted through a STC. There's certainly the Honeywell Smart Runway Smart Landing feature, which includes this stabilized approach monitor. There is a energy-based system available from Airbus, which is called the ROPS system, Runway Overrun Prevention System. And the same system is available from Boeing. It has a different name. It's called RSAT, Runway Situational Awareness Tool. And then recently, Airbus with NAVPLU, they teamed together. We developed with an airline and Honeywell a landing surveillance, which is a combination of the ROPS and the smart landing system. And this all falls in line with the recommended Eurocontrol European Action Plan to prevent runway incursions. So if we talk about runway incursion surface collision prevention, so this is also something which there was a European Action Plan published for this. So the root causes are typically a misunderstanding in the communication between the pilot and the air traffic controller, the complex airport infrastructure, the incomplete situational awareness on the part of a pilot or an air traffic controller, or some of the procedures. So this action plan was published in 2017 and definitely designed to improve the runway safety and the incursions. So if you look at this case example, this was an accident which was happening in 2016 in Shanghai, and you see a airport with two runways, 36 left and 36 right. And on the bottom of this little diagram there, you see a blue aircraft, which is an Airbus 320, 147 passengers. And this aircraft accelerated to take off from that 36 left runway. On the top right, you see an A330 aircraft, which came in with 266 passengers on runway 36 right, and it was taxiing, trying to cross runway 36 left. So originally this aircraft was cleared to cross the runway, but then it was actually instructed to stop and hold short of runway 36 left. Unfortunately, the stop instruction was missed. So what's happening is, and you see a representation here, the A320 is going to accelerate, the A330 doesn't stop there, and just because of there was a decision on the A320, they couldn't stop in time to avoid the collisions, and then they decided to really climb up with a indicated airspeed of 130 knots, and they barely made it. So this would have been a very fatal accident with 413 passengers. So there is still some investigation ongoing, but anyhow, the preliminary investigation suggested the main cause was a negligence by the tower controller and also on the A330 crew. Just this week, there was an Aero International magazine released, and there is a similar accident which happened actually on June 15 in Tokyo under good weather conditions, where a 787 tried to cross the runway, and then approaching 737 initiated a go-around. So there is not always a clear weather condition, certainly systems which could alert pilots. It would have been great having a system on board alerting the pilots of a traffic on the runway. So this is actually where another technology breakthrough was happening. It's called the Caesar Surf project, which aims to provide the pilots visual and audio warnings about approaching hazards on the runway. So basically, here you see on the top a couple of accidents which were significant, very severe, and then there is the EASA, which basically said the risk of the reported occurrence demonstrate to be very real, and it must be a priority for the industry to reduce the number of such events. And if we look at some of the statistics again, there is a runway incursion A and B occurrence. So basically it's two categories. Category A is a serious incident, collision narrowly avoided, and the category B is where the separation decreases with significant potential for collision. So if you look at the statistics here, basically it in the US region, it happens at 0.24 occurrences per million movements. And in the EU in 2016, there was a 12% increase over the previous year. So this is due to the dense traffic and the situations, weather conditions, and in end. And the projection is for a major carrier, 700,000 movements per year, that a category A event would occur 0.56 times per year, and a B category event would almost occur 4 times per year. So those are pretty much alerting figures. And just to bring this in a little bit better perspective, currently there are around 202,000 flights globally per day. So we're talking about movements here. So think about if an airline operates an aircraft 2-3 times, those are like 4 to 6 movements already. So pretty significant numbers here. So on the Survey project itself, the object is very clear. It should be a safety net to avoid collision between the aircraft. The system intends to assist flight crews in reducing the probability of runway incursions and collisions with the traffic, and the system achieves this by providing the flight crew with timely information visually in the primary field of view. And the coverage is basically all the runway areas, including the crossing runways. The inputs which are required, it's basically ADS-B traffic, which is collected by the TCAS computer. and it's basically airport runway geographic data, which is coming in this case from an enhanced ground proximity warning system. So a little bit of the concept on the top here, you see, for example, when an aircraft come in and a aircraft is aligning there, if the aircraft would not stop, there would be an alert. So this would have been the Shanghai case example we presented, where the A330 would have received a proper alert to be able to stop and avoid any of those category A cases. There is also, if you look at the second example here, when an aircraft comes in and another one is still aligned and hasn't proceeded to take off. So the approaching aircraft would receive an alert. And example number 3 is where, for example, the aircraft has not exited yet from the runway and another aircraft is aligned to take off. So there would also be an alert. The concept would be, an audio alert and, if possible, also to bring a visual alert into the cockpit. In terms of a roadmap, you see who is involved in this. It's Airbus, it's Honeywell, it's Eurocontrol, it's Dassault, IATA, certainly, all the regulatory agencies. And what we did is Honeywell did a lot of VOCs with operators. We did a lot of data collection. We used real TCAS data and replayed those, and it really demonstrates that this is a way to go forward. And you see that we are at the end of 2019 here. 2020 ADSB out mandate is basically happening already, and then there will be a period for a very large demonstration. So we hope to be quicker here and have the system installed in beginning of 2020. So in terms of airport operations, runway safety and efficiency, the challenges are that there is a fast-growing air travel, serious airspace congestion, infinite capacity from a regulatory perspective. There's definitely a need to maximize the use of its existing runways and airspace to reduce the delays while not compromising on safety. There are functionality limitations with legacy instrument landing systems, the ILS, and there are noise problems around the airport where certain noise abatement procedures have to be met. So looking at this, GBAS, for example, provides a very good enhancement to those things. On the top left, you see it says flexible digital approach path. So a GBAS system is a virtual ILS derived of GPS coordinates, basically, and you could stagger aircraft much better. On the bottom left, you see, hopefully you see this a little bit more clear. On the bottom left, you see that you could define procedures where you reduce the fuel consumption because you can have curved approaches and get closer to the runway and the touchdown point. On the top right, you see it requires no clear zones. I mean, ILS typically require a clear zone to prevent a signal interference, which is coming from terrain or structure. And also on the bottom right, you see it serves all runway ends. So with one GBAS station, you can do multiple runway ends, programming, and it's more cost effective because ILS, for example, it's only one runway end, and it requires periodic flight checks and a lot of maintenance activity. GBAS also enhances the category 1 and 2 approach capability. It's less disturbed by weather conditions. For example, in New York in 2016, there was a winter storm, and all the ILSs at the airport were basically non-functionality, but luckily enough, GBAS continued to work. There's also a lot of advantage in the enhanced wake turbulence mitigation for parallel runways because of the flexibility and the many more approach alternatives you can provide with those. So moving on to the weather radar, and I think the audience will receive another 2 poll questions. I'll just pause for a couple of seconds so you can answer those. So I will continue in the interest of time here. So how bad can the weather be? So there's also a little bit statistics on the UK Civil Aviation Authority, where there were like a total of 387 turbulence-related injuries to passengers flying with British Airlines during a period of 4 years. Each turbulence-related incident cost the airlines on average of $150,000. The total cost in the industry exceeds $100 million a year. And as the Bureau of Transportation Statistics, the weather costs 32.6% of the total delay minutes in a year. And maneuvering through bad weather increases the pilot workload, resulting in pilot fatigue, which is detrimental to safety. And several cases of damages to the aircraft have been reported. So if you look at traditional weather radar systems, so the tilt-based manual mode requires a pilot calculation to determine the cell tops. So tilt management is a key in improving the safety of an aircraft during the flight. Proper tilt management is really a requirement. The traditional radar systems also, they scan only a portion of the airspace in front of the aircraft, because typically you're using only 1 or 2 tilt angles to look at a weather, and you don't change it throughout the flight. But a proper tilt management would require you to change it if you want to analyze weather, if you change your range, if you change your altitude. The radar operation is typically restricted to only one view at a time. So in a lot of cases, there is not something like a dual operation possible. There is also no vertical awareness of the weather. So you only look at a certain altitude with a certain slice of the radar beam, and you don't get the complete vertical situation on the cell growth. Typical radar systems can also not remove the ground clutter from the weather, and this is also sometimes a little bit confusing. So a lot of experience and tilt management has to be used in order to find out if it's really a weather cell or a ground return, which adds to the pilot workload. And then there's certainly a limited hazard detection capability. So very experienced pilot, they do understand very well the atmospheric conditions. They know how to interpret the radar image, how to interpret scalloped edges, fingers, hooks, U-shapes. Those are the typical things you would use on a typical radar system. The technology breakthrough is going to a 3D weather radar system, which is basically, if you look on the top left side, the 3D Honeywell RDR 4000 interview system scans constantly from 0 to 60,000 feet, 320 nautical miles out, which means you capture all weather at the one time. It's regional independent. And what we are doing is, if you follow the arrow to the top right scheme here, we put all this data into a 3D buffer where it's stored in there, and then we can do good things like on the bottom left, you will see that we are having a database in the radar system where we can actually filter out the terrain. So we really would only represent the weather cell itself. So you don't need to care about ground returns anymore. You don't need to think about it. We really display what's important to you. And the database is basically a version we derived from the enhanced proximity warning system, because we have a very sophisticated database there. We invested a lot of money. So that's all good. On the bottom center picture, you see we do like a flight path scheme. So we try to show you only the weather you should be concerned of and which is ahead of you, but we're not hiding any weather. We are using a full color picture versus a crossed hatched pattern. And on the right screen, you might see this a little bit. I hope you have a little bit better image than I have here on my screen, but the solid ones are basically everything which is in your flight path, which is really at your altitude, a little bit above and below, and which is of concern for you. And to ease out the cell analysis, we use something which is called a manual or an altitude mode. And on the left side, you see this little, like a blue area. This is where you can set with a so-called flight level control. You can set a certain flight level and look at that specific area of a cell. So you could easily go to the cell top, and you would know exactly at which flight level the cell top is, and you could scroll down and you would see exactly, how the cell looks like, what the content is, how it originates. So recently, during a pilot seminar, the feedback was, we recognize if we hop into the cockpit and we see the radar with the flight level control. So that's the Honeywell radar. If you go on the right side, the right screen here, you see a couple of symbols. This is the hail and lightning feature. So the radar with its capabilities and the 3D buffer, we can look very thoroughly on the cell content. We can see how the cells are developing, and then we can put up hail and lightning icons, which are very easily to be detected by the pilot. We also, on the little left quadrant on the top where you see this little cursor there, you see a couple of cyan purple lines there. This is called the react mode. So basically, we are alerting you and saying, hey, there's still something out there, but everything which is represented there, it's much severe than you expect, and we cannot calibrate this in a good mode. So a couple more features on this radar system. This is acting like you have a single system installed, but it's acting totally independent for the pilot and co-pilot side. So you can do, different views, which is of great advantage if you would like to analyze a weather. So on the left side, pilot side, you could do your regular, I look at all weather, and on the right side, you could do your manual mode, for example, where you do put in your flight level, where you analyze, the storm top, the density, you could do a ground image on the right side. So it's totally independent, and there is no delay if you switch any modes. The modes are there immediately. So this is really looking like a independent control for both radar systems. What we currently have in the pipe is also a 2-level turbulence going out to 120 nautical miles. This is coming also from a lot of pilot VOCs we did. So we're really active in trying to see what is the industry interest in improving, enhancing, and providing more safety to the community. So this was one of those things. And as you can see, there is a 2 level. So we're trying to use the solid versus the crosshatch pattern. And on the right side, you see that we will put in a cell tracking for diversion planning. So we had a case study with Air India, and the business issue was basically a bad weather with bad weather warnings by existing systems. Solution was basically using the 3D radar system, which looks at 0 to 60,000 feet, 320 miles out, and then afterwards, after the radar was implemented into the system, Air India reported substantial improvement in the ability to see upcoming weather systems and turbulence, and to make the necessary steps for the earlier weather avoidance. On customers which are using the hazard functions, this is where you get the hail and lightning icons. And they typically report 50 more towards 70% reduction of this. And this is also proven by some of the drone inspections they do with the aircraft. Another project we're working on is the high altitude ice crystals. So there's NASA involved, Airbus involved, and Honeywell is involved. And on the bottom, you see that there was a campaign out there where the consortium was looking for a radar system, and Honeywell was clearly chosen here for that kind of high altitude ice crystal project. Just doing a quick reminder on safety mandates, because it's like 5 to 12 already. There is the DO to 60B compliance for the ADS-B. So this is, the 7th of June 2020. So I urge all operators who have not yet done anything in that regard and need to comply. You really need to hurry up. You need to get your orders in. You need to think about how you upgrade your aircraft, consider aircraft downtime, because time is really running out very, very quickly. And on the same line, there is the PMCPDLC requirement. So a lot of airlines have already a system installed, but it might not meet the current requirements, which were also a little bit changed. We talk about a white paper. So this is actually going to be, have to be compliant 5th February of 2020 with the forward fit and retrofit. So this would basically conclude my presentation. Thank you very much for listening, and I give it back to the coordinator.
Well, thank you very much, Alois, for that presentation. And now we are going to shift to our pilot on the panel today, Christoph J. Kemeny. Christoph, over to you.
Well, hello, everybody. Thank you for giving me the opportunity to speak here and share some insights from the pilot's perspective. I have chosen the compass here as my first slide, as this is always the symbol of where I am and where I'm heading to. To know where I'm heading to, I have to know where I come from, and that has been done in the previous presentations, to have a look back in the mirror, what we have accomplished so far, where we are. And the left side slide will show what Alois actually has talked about, the future of how a flight deck would look like with respect to what Honeywell will see. Today is a very historic date. 50 years ago, the Apollo 11 Saturn V rocket went into the sky to put the first man on the moon. And when coming back, Neil Armstrong was asked, when he took over manually the lunar landing, which was not as per mission descript. The mission rule was to have an automatic landing on the moon, and that was per system design. Well, Neil Armstrong, as you all know, has chosen to switch off the automatic landing system and had basically what we call a semi-manual or semi-automatic landing. On the ground, he was asked in a review, and he said, in all the simulation, in all the simulators, we were abort-minded. And that's what we see in our simulator training today. Yes, we are go-around-minded, we are safety-minded. In the simulator, you will never find a runway incursion or runway overrun, nor would you find any of those accidents we are talking about. Being abort-minded in simulation, he stated, when I was going down on the moon, I was landing-minded. And that is actually what, and I like this historic fact as a symbol of how we use our safety systems, how we use the training in the full flight sim nowadays, that in the sim, we are always this safety-minded, go-around-minded, but when pilots are actually doing their mission, they are landing-minded. So we have to keep that in mind when we talk about minimum training. When we talk about training can fix everything, we should keep that in mind, that a pilot is always mission-minded, and we should look for how we can implement future systems accordingly. FMS, Flight Management System, has done a great job, and I will run through that a little bit more quicker. We are all aware that flight management systems were a great help in making flight more efficient and even more safer, as we know now where we are and where we are heading to. Controlled flight into terrain, a lot has been said about this. Yes, all our systems, especially the EGPWS system, has helped us great to eliminate that as the largest safety risk in aviation. So that system actually helped us do a great job. And this was one of the systems which could actually be used in a full flight sim in a highly sophisticated way to do the training properly. TCAS, great thing. On the right-hand side, you will see the vertical speed indicator, and most of the aircraft which have not had head-up display symbology are still required to fly that with a vertical speed indicator. Most of the latest aircraft, like the A350, they can do that via or with the help of the autopilot. When you have opted to buy this option, what we see is here highly sophisticated or much better, easy to understand symbology. It's a clear, safe area where the flight path symbol has to be placed into to comply with the TCAS evasive maneuver. So that is a pretty strong also call to implement head-up display symbology on the head-down display, which Airbus and Boeing and Embraer and Bombardier with the C-Series, now Airbus as well, is going to. Weather radar system is an increasingly important system, what Alois has told us. However, I would say from a pilot's perspective, what I know from the industry, and I think I can say I have a pretty good network, weather radar is the system with the poorest training and with the least understanding by pilots. Why is that? Because the simulator cannot do the proper training a weather radar system would require a sim training to do. And the full flight sim is probably not the best location to really learn and understand a weather radar system. And Alois has told us a lot about those great functions and features today's weather radar system can provide. Here is something, and you have probably noticed that, training is one of my top priorities to increase safety performance indicators. We need something else besides simulator training to really make full use of those safety features, and that are, I would call it like a weather radar app, an interactive weather radar app or something like that, like this, for a mobile device or for a computer, where pilots can really play and fully understand the capabilities and the controls of a radar weather systems. We just don't have the time in the sim to go through all those great features. So here is my it's on top of my wish list to increase training capabilities and look for new training apps or new training options for the pilots. I'm awfully sorry. I should have a different picture here for RAS. RAS, we have them on our aircraft, like the Embraer or the CRJs or the Airbus. RAS is a great display, and it really increases situational awareness, and that's what we need. Yes, I agree, RAS does not require a lot of training. We can easily put that in a sim, and that works well. What has industry done? Industry is looking from a different perspective, not only a technology, but also what pilots can do. So how can we improve flight path management? How can we increase the monitoring, go around decision making and all those features? So there are really good publications out there, what we can do. However, I would caution everyone, training is not everything if it is not done properly, but if we can have the time, and that is the The problem in the industry, we need more time to train those things, and the pressure to reduce the training time is getting more and more. Flight mode enunciator awareness is one of those key elements from that publications where we actually do have a lot of attention on from the very beginning in the training to increase those flight mode enunciator awareness. So any engineering effort should also address the optimization and the evolution of those flight mode enunciation awareness so that the pilots will get presented the actual state of the aircraft in a proper way. Okay, yeah. So automation in aviation, yeah, we're using a lot more automation features than the guys a lot of years ago. So we have to face that, and this is in everybody's mind, how to increase or how to use the automation in an appropriate way. This is a training effort. This is procedures. So we took that from those publications. We took a lot of those intelligence out and put it directly into training, how to use the automation in a proper way. So automation must be effective. It's not only to put any system on the aircraft, it has to be well thought. Interaction of those systems and man-machine interface is a highly important part of that development, as you know. So I will skip that a little bit as we have our Alois, and we have seen that before. Vertical displays on our latest aircraft designs is for me and for a lot of other pilots a highly critical and important part to have more and more information displayed on the vertical path as well on the lateral path as well, as this will increase situation awareness. Increasing situation awareness is part of increasing our safety performance indicators. So anything that we can put in there is highly recommended. And now here I come to one of my favorite subjects. It is the head-up display system. Head-up display systems will give you a conformal display of the flight path trajectory. It's the flight path and energy state awareness with the acceleration caret and the flight path indicator. We have heard a lot during the last two presentations on risk analysis. I would even recommend to have in the future to have risk analysis like what we saw from IATA to distinguish between non-head-up displayed aircraft and head-up display aircraft to see where the differences are. As we see, or from the industry data we have, that head-up display significantly increases the safety of our aircraft. When we look at hard landing, when we look at tail strike, when we look at runway excursion, undesired aircraft state, unstable approach, go-around, approach stability, we see that aircraft actively flown with a head-up display system during every approach will give you much better numbers on this than non-head-up display equipped aircraft. When we go to UPRT training, and this is one topic I would like to raise for your thought. Yes, we have implemented UPRT training. However, when we look at like ILS training or go-around stability, we do have from IOSA or LOSA or whatever, or from FOQA or flight data monitoring, we can actually draw the data and see how much better we are. UPRT training is leaving us alone since we have no idea of how good we are and what we are doing. And we know that every UPRT training in a full flight sim has its significant limitations since we are missing body sensations for the pilots, which is a highly important factor. And I can tell you this from doing UPRT training in a G-load simulator with 3 Gs on forces. So here we do not know how good we are in training as there are no data out there. What we know is from companies using a head-up display systems and actively displaying G-load in the pilot's field of view with a G-load doing any recovery, that those pilots are doing much better in recovery than pilots just doing something. So head-up display can increasingly or significantly increase the overall safety of an airline operation. CPDLC, yeah, I like that very much as I'm flying the A340 now. So CPDLC in any part of the world where we can use it is workload reducing and thus increasing safety. This is all done and all those factors so that we have an effective team in the cockpit. Everything what we do in adding new systems on the aircraft to increase safety, my recommendation would be to look at how can it be trained, as we should train as we fly, fly as we train. And so thinking of training from the first day is one of my top priorities. So have specific systems in a lower level device might be much more efficient in training than putting it all in the full flight sim, or even leaving it alone with less training remark and just putting it on the aircraft and having pilots not trained. The go-around decision-making project, we have worked on this so far. There are now, as you may know, Air Canada and Porter Airlines have now reworked their policies on a decision-making to take the stable approach criteria away from the go-around decision-making point. Air Canada is now having that 1,000 feet stable approach gate, and the go-around decision gate will be at 200 feet. Porter Airline has that at 100 feet. So we see that there is an evolutionary process going on in making go-arounds more efficient. I would just like to draw the attention to you that getting to 100% go-around execution is not in the interest of any airline, as this would be highly costly, and we would not have looked into additional risks when every unstable approach leads to a go-around. As well as not every unstable approach is a risky approach. So this paper has done a great thing. We are continuing to working with it, and there is work in progress. What else can we do to increase safety? Enhanced vision is something that the business aviation has completely encompassed and are using that. This would be in the future, from my point of view, highly desirable. And Airbus is now also going to invest in enhanced vision for the Airbus A320 family. Synthetic vision, that's what we see on Honeywell system as well. Great system. This is all adding to the situational awareness, and this will be able to increase situational awareness if done properly and if all the limitations of such a systems are well understood by the pilot. Alois has talked about those things. They will increase safety, so flight deck technology, procedures, so what I have talked so far, what we can take from the industry intelligence, training aids, and this is something I would like to draw your attention again on this. Anything that comes from a system point of view, technology has to have training from the first day. It will increase safety. We're looking at man-machine integration. And if all comes together, I would call upon not to look what can increase safety from an either-or system, but more to both systems or both and a point of view. Enhanced flight safety, that was it from my point of view, and thank you very much for listening.
Christoph, thank you so very much. That was a very interesting presentation. Now, unfortunately, because we have run over with all of this amazing content, we are going to have to close out our webinar. However, those of you who have submitted questions, they will be forwarded to the panel and you will get a response. So thank you so much for those questions. Well, it's time to sign off from London. I'm Dee Dee Doak. I'd like to thank our guests Gerardo Hueto, Alois Sankt Johanser, and Christoph J. Kemeny. Goodbye from London.